The beginning of the fusion between humans and machines may have been marked by the titanium heart that now beats inside the chest of a living man. The humanoid robot Mercury, from Elephant Robotics, is being developed to serve as the body for artificial intelligence. The UK Army, in its quest to create a super soldier, is developing and testing wearable technologies that, among other functions, detect enemy lasers and control drones. AIRB has created an advanced helicopter that can fly at the same speed as an airplane. Scientists have created a wearable technology that allows a connection between a human's mind and a robotic dog. These and other technological innovations will be presented in this episode. Stay with me until the end, as this is what we'll be talking about in today's video. Let's get started. Ocean Energy recently installed its impressive wave energy converter buoy, named OE35, off the coast of Oahu, Hawaii. Weighing 826 tons, this monumental structure is located at the United States Navy's Wave Energy Test Site and will soon be connected to the state's electrical grid. Measuring 38 meters in length, 18 meters in width, and with a draft of 9 meters, the OE35 has already become a familiar sight in Kaneohe Bay, on the windward side of Oahu. This innovative system has been tested not only in Hawaii, but also in Scotland, as part of a $12 million project funded by the United States Department of Energy and the Sustainable Energy Authority of Ireland. With a potential production capacity of $1.25 million, the OE35 harnesses wave energy through a dual airflow system. Unlike many wave energy systems that use the compression of an air column to drive a turbine, the OE35 stands out by using a turbine based on the Wells turbine principle, invented by Alan Arthur Wells. This low-pressure turbine can continuously rotate in the same direction regardless of airflow, eliminating the need for complex mechanisms to handle bidirectional airflow. The Ocean Energy Group plans to commission the OE35 soon, connecting it to Hawaii's electrical grid via an underwater cable. Although $1.25 million is not a huge amount of energy compared to the state's total demand, this project is an important step towards a renewable energy future. After more than a decade and a half of design, testing, and construction, we are excited to finally take this major step towards commercialization with our world-class device, said Professor Tony Lewis, Chief Technology Officer of Ocean Energy. This international project arrives at a critical time as the world urgently needs to accelerate decarbonization with innovative technologies. The OE35 may be a harbinger of a renewable energy era, transforming how we harness wave energy for a more sustainable future. We will continue to closely follow this energy revolution that could change the course of our environmental history. Elephant Robotics has been dedicated for years to research and development with the goal of bringing robots to millions of homes, promoting the vision of an Enjoy Robots world. Since the launch of the P&C series of collaborative industrial robots in 2016, followed by the Mobot 280 in 2020 and the MyBee in 2022, the company has been distinguished by releasing 3 to 5 robots annually. The Mercury series, launched this year, promises to revolutionize the landscape of non-human robots by offering intelligent models for research, education, and domestic environments. The Mercury series goes beyond advanced prototypes and demonstrates Elephant Robotics' commitment to creating innovative and practical humanoid robots for mass production and continuous use. The Mercury X1, a wheeled humanoid robot, combines advanced functionalities with mobility, equipped with NVIDIA Jetson controllers, LiDAR sensors, ultrasonic sensors, and an 8-hour battery. It is ideal for a variety of commercial and exploratory applications. On the other hand, the Mercury B1 is a semi-humanoid robot designed for sophisticated research. It features 17 degrees of freedom, dual robotic arms, a 9-inch touchscreen, an NVIDIA Xavier control chip, and an integrated 3D camera. The B1 excels in machine vision and VR-assisted teleoperation, with its voice and LLM integration representing significant advancements in human-robot communication. The Mercury series has been designed as the ideal hardware platform for embedded AI research, supporting advanced algorithms and practical applications. Its compatibility with NVIDIA's ISX facilitates real-time learning, enabling integration between virtual environments and physical robot interaction, making it ideal for studying large language models and embedded AI. These advanced features provide a reliable and scalable platform for exploring the frontiers of machine learning and robotics. For the first time, A fully mechanical heart developed by Bivac Corp has been successfully implanted in a human, utilizing the same technology used in high-speed rail systems. This innovative heart represents a significant advancement in keeping patients alive while they await a biological heart transplant. Since 2013, Bivac Corp has been working on this device, which uses a magnetically levitated rotor to pump blood without friction, enhancing the device's durability. Although not the first artificial heart implanted, the pioneer was in 1969, this is the first to use such lightweight and efficient technology. The total artificial heart, TAH, is about the size of an adult fist and uses a rechargeable external controller, pumping blood at a rate of 12 liters per minute, allowing an adult to exercise. Unlike other artificial hearts that rely on flexible polymer diaphragms, Bivac Corp's mechanical heart has no easily worn components, promising greater durability. The company's main goal with this titanium heart is to keep the patient alive while awaiting a definitive transplant. Daniel Teens, founder and CTO of Bivac Corp, stated that this achievement was made possible thanks to the courage of the first patient and their family, as well as the dedication of the team and collaborators. The advanced maglev technology used in the TAH brings the company closer to offering a crucial option for patients with end-stage heart failure. The next step is to implant the titanium artificial heart in 2 more patients, who will be closely monitored while awaiting permanent transplant surgery. Heart failure affects more than 25 million people worldwide, and the demand for heart transplants has doubled in the last 30 years, with over 3,400 people on the waiting list. If Bivac Corp's titanium heart passes clinical trials, it could save many lives. And the revolution in advanced heart failure treatment is just beginning. Stay tuned for updates here on Gyros Tech, and make sure your subscription is active. The Airbus Racer, an innovative helicopter, has achieved an impressive cruising speed of 400 km/h, surpassing all expectations. This remarkable feat was accomplished under the European Research Clean Sky 2 project, showcasing the strength of European innovation. In a press release on July 23rd, Airbus announced that the Racer not only met, but exceeded its target. Bruno Evans, CEO of Airbus Helicopters, praised the dedication and hard work of the 40 partners from 13 European countries who made this innovation possible. In just 7 flights and about 9 hours of flight testing, nearly all stages were completed. He also highlighted the aircraft's aerodynamic behavior and stability as promising and mentioned the upcoming phase of tests, which will include the Eco Mode. The Eco Mode will allow one engine to be turned off during cruising to reduce fuel consumption and CO2 emissions. Thanks to aerodynamic optimization and the innovative Eco Mode propulsion system developed in partnership with Safran Helicopter Engines, a fuel consumption reduction of about 20% is expected compared to helicopters of the same maximum takeoff weight category. Additionally, the Racer aims to demonstrate how its architecture can contribute to reducing the operational acoustic footprint, emitting less noise while flying. Combining unique designs, this machine features a special aerodynamic fuselage, a helicopter rotor that generates vertical lift for vertical takeoffs and landings, and a fixed wing that contributes to 40% of the total lift during flight. This innovative project promises a more reliable and efficient flight compared to traditional helicopters. On April 25th, the Racer completed its inaugural 30-minute flight, marking the beginning of a new era in high-speed helicopter technology for Airbus. Based on innovations from the company's X3 demonstrator, the Racer represents a significant step forward for the future of aviation. With a development cost of 12 million euros, the Racer has the potential to transform the industry, as it takes off smoothly like a helicopter without the need for a long runway, but flies at high speeds like an airplane. Once finalized, this innovation could completely change the global aviation landscape. The British Army is set to revolutionize the battlefield with an array of wearable technologies, including devices capable of controlling drones and detecting enemy lasers. The 2nd Battalion of the Royal Anglian Regiment, based in Leicestershire, will be the first to test this innovative technology, assessing its utility and learning to use it effectively. Among the technologies being tested are devices that alert troops when lasers target them, detecting the wavelengths and issuing a warning for necessary countermeasures. Another innovation includes devices that enable soldiers to directly operate unmanned aerial vehicles. Additionally, thermal drone detection systems, laser rangefinders, advanced digital optics for day and night vision, and a mesh network that extends communication range by bouncing radio signals from soldier to soldier are being tested. The digital system is standardized and offers customized control for each specific mission. One notable feature is the strobe warning system mounted on helmets, which can identify friend or foe and includes an electronic beacon to help locate the soldier. Another important technology is the Smart Hub, an integration center for power and data supply to all devices, providing better asset visibility on the field and device interconnectivity, allowing troops to send data, images, and videos on the move with ease. Scientists from the Defense Science and Technology Laboratory are conducting these tests, demonstrating that small changes in infantry tactics with reduced command and control, communications, computing, and information systems can significantly improve operational outcomes. The main goals include increasing the pace of battle and enhancing real-time decision-making capabilities, helping troops think and act faster than the enemy. Maria Eagle, the Minister for Defense Procurement and British Industry, stated that this cutting-edge technology will enhance operational lethality and battlefield awareness. She emphasized the ongoing collaboration between government, industry, and scientists in this innovative project. The next phase of testing will explore vehicle-mounted options and the development of a joint soldier system with UK allies. According to the British Armed Forces, further development and experimentation will continue over the next 5 years, evolving as new technologies become available. Robotics has unveiled its first delivery robot, the One. This robot not only accompanies staff inside stores, carrying customer orders, but also autonomously navigates city streets, reaching speeds of up to 32 km/h for deliveries. Commercial implementation has already begun, marking a new chapter in the delivery robot revolution. Over the years, companies such as Amazon, FedEx, Walmart, and Uber Eats have experimented with various delivery robot solutions. However, Robotics, a Californian startup, is taking a different approach by developing a low-cost vision system combined with advanced artificial intelligence, allowing the robot to navigate without pre-marking. In 2022, Robotics introduced an innovative camera sensor called ViSense, which combines low-cost image sensors with modern computational imaging techniques and machine learning, resulting in a high-resolution and cost-effective robotic vision system. Additionally, the company developed an AI model named ViewDrive, which trains the robot using simulated and real-world data, eliminating the need for HD maps and LiDAR sensors, relying solely on the ViSense vision system. According to the project leads, it operates with a state-of-the-art end-to-end neural network similar to large language models, LLMs, using a base of input and output tokens. The One is essentially a four-wheeled electric delivery pod, measuring 1 meter in height, 1.8 meters in length, and 0.67 meters in width. It can reach speeds of up to 32 km/h and has a maximum range of 112 km per battery charge. Upon reaching the delivery point, it can climb the sidewalk, stop, open its side door, and remove the package with its robotic arm. The storage compartment can carry up to 45 kilos of goods, adjustable to 90 kilos. According to Robotics, the One is being tested by a major e-commerce player, whose name has not yet been revealed but plans to implement 2,500 robots starting in San Ramon, California, before expanding to other U.S. cities. The company promises to transform the delivery process by offering an efficient and futuristic solution for the e-commerce market. Did you enjoy the video? If so, please subscribe to our channel. This helps us grow and gain more relevance on YouTube, allowing our content to reach more technology enthusiasts. On your screen, you can see 2 new video suggestions from our channel. Keep watching and thank you very much for following us.